Hi, this is Jeremy Hu from Dust3D. Dust3D is a quick, low-poly modeling software for indie game development. First, I want to thank Epic Games for the MegaGrants. Dust3D has been highlighted in the first round of Epic MegaGrants. And thank to my GitHub sponsors. Let me read the names. Thank to Igor, Robert, Aaron, Shinji, Lewis, and Hugo. The RC7 is being heavily developing. I'm borrowing this window for showing the sponsors. Every sponsor will be recorded permanently and showing the software. Thank you. This video is based on the version of RC6. It's the latest released version. So I will close the RC7 for now. By the way, I want also thank to all the people who make video, post article, share link, and tweet this software to let more people know about it. I'm really appreciate. Okay, let's start to explore the modeling fundamentals of Dust3D. When you open the software, you can open an example model from the File menu. So I just opened the dog model. The UI is simple. This is the menu. This is a toolbar, and this is a path tree. There are other dog tabs. In this video, we are focused on modeling, so you don't need to touch other parts. From the menu, there is a very important options, combining mode. This is the default mode. When you create a new part, it will be set to this mode. We will discuss this later. If you don't know what this means, just keep it as default, normal. And another important setting is the flight shading. You can talk this setting to see the result changes. See, if you turn on this, your model will have a low poly. Feeling. You can turn on the wireframe, turn off the wireframe from the view menu. So if you turn off the flight shading, the model will be smoothed out automatically. But some people don't like the smooth. They prefer the low poly feeling. So just turn on this shading option. By the way, the shading option also affects the final result you exported. So if you want your exported result have a low poly feeling, you should turn on this option. The default option is the flat shading being turned off. So the model will be automatically smoothed out. There are other settings we're not going to talk about in this video. The path tree is when you put a node on the canvas, the path will be automatically created. So the canvas is normally a reference sheet. You can change this reference sheet from the File menu, change reference sheet, and load a image you made for this. Like this, if I had all the nodes, you can use the shortcut H to, you don't select anything and hit the H key, it will hide everything automatically. And if you hit H key again, it will show up. So this picture is taken by me. This is the front view. This is a side view. Normally, front view is represent the x line, and the side view represent the z line. So the positive z is the heading forward direction. So this way is the positive z. This way is the positive x is this. So you should make this reference sheet in other software like Photoshop or GIMP. I made this picture in GIMP. You need to take a front picture and take a side picture and combining them in the photo editor software in GIMP, for example. Okay. The modeling progress is normally we put the nodes on the canvas, cover the shape of the background, and the polygons is being generated automatically. We can tweak the settings of each part to affect the final result. So what is a node? A node is a circle, you see, and the edge connect nodes. See, this is the edge, this is the node, and when you double click one node, the whole part will be selected. The part is actually a tuple. So remember the node, edge, and the tuple. So a tuple is a part. You can use the shortcut F to highlight the part in the part tree. For example, if I scroll it here, and if I want to highlight this in the part tree, I just move the mouse on and hit the F key. See, show up. And if I want to select this part from part tree, I can right click, select. See, the front view is being selected, and sometimes you want to select this view, the side view, but currently the front view is being selected. How you can change the view selection by just click the E key, QWE, the E key. You can switch the selection, different profile of the selection. See, the front view, side view, front view, side view. And the front view is use the color of red. The side view is use the color of green. Okay. So from the part tree, you can see the name like right, front, foot. These different parts can form a component, or this one is actually a single part component. So this, instead of saying it's a part tree, you can say it's a component tree. So the final mode is by combining all the components. There's a root component, and there's sub components. One component can contain other components, like these three parts. Each part is actually a component, and this component have three sub-components, and each component is a part, and you can rename it, or you can move it to other component. The component is called group. So sorry for there are many, maybe some confusing here. So if you want to create a new group, just right click any of this and create new group. In the end of the list, you can see there's a group 5, and then you can move this to group 5 or move others. So you can rename it something. So this is the path tree or component tree or group tree. Okay. I just talk about some shortcuts. Let's say some shortcuts are very important, like the E key. I just talk about it. And there's another shortcut, A. A means add. A is add a node to the canvas. A, you can say, you can use the ESC key to cancel it. Or you can click this plus icon from the toolbar. See, it's the same as you just click the A. See, and you can right click to cancel it. Or you can click the ESC key from the keyboard to cancel it. And there are many other shortcut lists. You can see from the, you can check this document, the shortcuts. I will link this in the description. There are many other useful operations don't connect with the shortcut, like for example, okay, just like this. So sometimes you may make the red nodes on the right side of the canvas and the green node on the left side, but all the other red nodes are on the left side. So you can just double click it, and from the edit menu switch XZ, or from the right menu, right context menu, switch XZ. See, it's switched. And there's one very important command I used mostly, not command, it's a shortcut, it's a comma key on the keyboard. It's a rotation. You can rotate. And the dot key is rotated clockwise, and the comma key is rotate it anti-clockwise. counterclockwise. So you can also use the right, like rotate 90 degrees. But if you want to rotate 1 degree one by one, you need to use the shortcut. You can double click to select one part, or right click and select wall, or just select part. Another very important suggestion is don't start mode without a reference picture, reference sheet. Don't start mode without reference sheet. Don't start modeling without reference sheet. Okay, I say 3 times to emphasize this, because if you don't have a reference sheet, you don't know where you need to put your nodes. But if you have a reference sheet, then everything became easy. You just follow the shape of the background and put 2 views of the nodes on the canvas. You can take photo of the things you want to mod, or you Google the front side image and the side of the image and compiling them. The recommended image size is the 1024 with width and 512 pixels is height, and trim the top and the bottom margins of the image. What I mean by that is make the height of your image cover the whole canvas. Don't leave space up and side, upside and downside. So, and make these 2 sides of image the same height. And put the front view on the left side, the red color on the left side, and side view on the right side, and with the head forwarding to left. Okay. When you have the image, think about how you are going to model it, how you are going to split it to tubes. Like this one is a tube. When you look at the image, think about what's the shape will be look like. Like the body, the main body is a tube, and the legs, each leg is a tube. This one, tube. This one is a tube. Head is a tube, and each ear is a tube, and each tail is a tube. Okay, think all the tubes of the model. Just look at the background image. This actually is not easy. You need to think carefully before you start to modeling. And then you can see the small triangles. This is the model center. So if you move this, your center, your origin of your model will be changed. And the front center, the front view, the center in the front view is very important. It will affect the mirror information, the mirror result. So basically, the modeling progress is thinking about each tuber you're going to make, and after making it, you can adjust the position of each tuber and intersect them, like this leg with the body. Let me change the poly count setting. Okay, so this leg is the front leg is intersecting the main body. See? You are intersecting all the tubers to make the final result. Let's delete this. Maybe hide this. You can click this link or unlink mini button to remove it from the final result. Okay, next very important feature is the thickness deformation. Let's use this as the example. This the color, you can see the color is different. The color means the combining mode. If it's normally it's red, but this one is different. So let's check the mode is uncombined. The uncombined, we talked before, we can set the default combining mode here. And normally the default mode is normal. We can change it. So let's say this one, if I move it here, and if I change this mode to normal, see, it will intersect with other parts. See, it will intersect. So if the model is uncombined, it's not intersect with others. But this will make your model non-manifold, which means your model is separated. It's not one connected model. So if you want your final result be one connected model, you should not use the uncombined. And there's another model is inversion. Inversion means subtract. See, it subtracted itself from the body. This is real-time boolean calculation. Okay, leave it as uncombined, and let's demo the thickness deformation. There are two directions of the thickness, like this one. See, you can change the thickness. So sometimes when you are modeling, you can see the part, you didn't set the color as red, but this red means the part have some problem. It will calculate it as a bad mesh. So if you see the red color, that means you should adjust some settings, like this one. We should adjust the thickness. with another direction. You can change. Okay. So, what's the direction it's deforming? There is a automatically calculation of the base plane. The base plane decides which direction it deforms, which two directions it deforms. These two directions are perpendicular to each other. So, there is a base option. Dynamic means if I see this, if I change some node, see the direction. It's dynamic means it's according to each node itself calculate a base normal direction, and let's say the deform will follow these two directions. So sometimes you don't want this. You can choose the average. I think the default mode, the default base mode is the average in the RC6 version. So the average means it's sum up of all the base plane, base normal directions of all the node, and calculate the average direction. So this looks more uniform. And there's other options like side plane and front plane and top plane. Okay, normally you just use the average or use the dynamic. Let's see this as an example. Okay, see this as an example. This leg. So thickness, see. Current is set to dynamic. We can change to average. See, the average make the deform more uniform. See, the deform direction changed. See, dynamic will have more variations according to each node. Okay, this is the thickness deformation. Another important feature is the cut face. Let's use this as an example again. The cut face. There are 5 predefined cut faces. You can choose. See the changes. Let's remove the deform. Okay, now you can see the cut face changed. Okay, and there There's a rotation. You can rotate the cut face. The cut face, because I'm not a native English speaker, so I'm not sure if the cut face makes sense in English. The cut face is actually an extruding face. When you are modeling, it's using this face to fill the geometry. I'm not sure if I explain clearly, so that there are 5 predefined cut faces you can change, and you can notate it. And this one, there is a hollow option. Like if we, okay, let's make a new one. This one, the white, this one, see? So the hollow option is make a hollow. Okay. And besides this 5 sorry, it's 4, it's not 5. The 4 predefined cut faces, you can define your own cut face, like here. This one is actually a cut face. See, the target is cut face, it's not model. This part became a, okay, let's make an example. Just use this. Let's turn off the, okay, this one. Let's make okay. Let's make this. Choose the target. It's cut face. See the color changed to red. It's actually orange. Okay. Now it's become a cut face. Now you can use this in another part, like this one. You can choose it as the extruding face, the cut face. See? Now I can change this, and it will affect this. See? Okay, so the user-defined cut face is very important when you make some shape which are not so which you cannot use the predefined shape to represent, just like this one. This one is using a user-defined cut face, so it's this. So the cut face, you can make two. There are 2 ways to define cut face. The shape of the front view, actually the shape of the front view means red. The front view define the cut face. You can see this have another view. here we are not using this to define the color face. We are using the front view. So use the red color to define the color face. This one as well. So this one, another view is this. Okay. And there are two ways to define the color face. One is a ring or a tuple. If you use a ring, the origin of each node define the cut face, and a tuple, the origin and the radius of each node define the form a cut face. Like this one, the cut face is actually like this, and this one, the cut face is just to connect all the origin of the node. Okay. With the user-defined cut face, you can also, let's see this, you can also rotate, see the direction change. Okay, and then there are two buttons. You can rotate to specified degrees. Okay. For the this has become a little bit messy. Let's reopen it. About the combining group, the combining mode, we can combining these parts or these components together using the combining mode is specified. So actually, as I said before, this is a real-time Boolean operation. So it's not just that, because sometimes when you move it, you can see some very, see here, just see very, by the way, you can also use the direction, up, down, left, right key on the keyboard to move it. So sometimes you can see really bad topology being generated. Okay. Just okay. See, this topology, this mesh is very bad. This is the trivial triangles being generated by the Boolean algorithm, the union algorithm of these two parts. So actually, there is an algorithm to smooth out this. The logic of this algorithm is remove these verticals, the same verticals, and then recombining the two parts. So if we see the bad geometry being generated, that means after the rebinding, the mesh is not manifold, or something forbid it to continue. So it fall back to the original Boolean algorithm. So this one is bad, but you can change it by slightly move the position, see, or change the radius, and it will affect the final result. See, so actually there is an algorithm behind to do the heavy works for you to remove the seam verticals and the bridging and the filling the hole and to get the final good mesh. Okay, so if you see, if I change this, for example, if I change this cut face to this one, you see the geometry changed. Sometimes you see the very bad meshes being generated. Don't worry, just move it a little bit or adjust another part a little bit to make the final result looking good. Okay. I forgot to mention this is a subdivide option. You can choose each of the cut face. You can still use the subdivide option to make more cuts or the chamfer. See, this is really bad geometry, but don't worry, just adjust the position or rotate it or change the subdivide level. Just remember there's an algorithm behind it. But you need to move it or adjust it to get the good result. Okay. And another important feature is the remeshing. The RC6 version is using the instant meshes to do the remeshing. So when you when you open this dog model in the example menu, it's actually being remeshed. So the original is this one. The original. And I have choose you can choose the poly count you want, like medium poly. It may be there are some holes being left, such as the tail. You can see the tail. So you can change this to higher poly. Just 1 second, you change the whole geometry. So this is using the instant meshes. It's a very nice library for remeshing. It's built in to this software. See? So normally you don't do this when you are modeling. After you finish it, you can change the poly count. Okay. And actually you can change some part, like the whole part, you don't change it, but you need to change like this. Okay, let's see. You can change this. There's a poly count. See? You can change each component. See? Okay. The W key, you can turn on and turn off the wireframe. Okay, for the color, this icon, you can change the change the color. And let's see the tail color. Change it to a darker color. Okay. And there is a very important option. You can like this. You can see the sharp edges. The color look very not smooth. You can use this solubility. That means it will affect the neighboring parts. See? Use the thing of the flat shading. See? See? It's affecting other parts. Okay. Okay. And the counter shaded. This is the, so you can Google what this means, and if we turn on this, you can see original. Okay. See? See the difference? It automatically detects the body and fill the white color for you. Okay. Okay. Most important features has been covered, and they export. You can export as OBJ files or export as an image. The image is just the render result of what you see, and you can see if you want like this geometry, you have chord, you have triangles. If you export as GLB or FBX, the export result will not contain the chords, just as all are triangles. So if you want the chords being preserved, you should export as OBJ. The OBJ only export mesh, so the UV and the animation and other things are not included in the object file. So the object is for export and further processing in other softwares, and or for 3D printing. Most of the 3D printing manufacturer support importing object files. So, or you can convert the object to STL or some other formats from other software. So if you want the codes being kept, use OBJ, and if you want to use your model in Unity, use the FBX. the Unity supports importing FBX format, and Unreal Engine has a GLTF plugin to import the GLB file, and the Godot engine supports importing GLTF as well. So the UV is automatically wrapped, so you don't need to worry about it. Okay. Okay, this is today's video. Hope you like it, and this channel has been marked as kids friendly, so the comment section is being disabled by YouTube. You can leave your comments to our forum or talk to me on Twitter, link in the description. Thank you all, and see you next time.